Hey everybody, let's go ahead and get started. Let me go ahead and publish my tweet. Right now I'm all good to go. I hope everybody's having a great day so far. Yeah, sorry I had to miss yesterday's stream. Just a lot of stuff coming up, but good tonight. Right. So I went ahead and started a sauna thing for here. Pretty empty at the moment, but I'm sure it will fill up pretty quickly. For now, we're going to try and make the shadow cutout, at least as much as we can tonight. Let me pull out this blog post again for the effect that I'm trying to recreate. So imagine this is a platform and this is a light source. So as you can see here, what we're going to kind of do is basically count up every vertex of the platform colliders and then shoot a raycast from the vertex outwards, and then we'll find the point where it collides with the outside of the screen, and then that will be the other vertex, and basically we'll just create little squares, or not technically squares, but quads that will go out for each edge of every collider. I mean, there's probably ways we could do it quicker, and raycast is probably a little overkill because my instincts tell me that it would be quicker if I did this just with pure math instead of getting Unity's physics system involved, but I wonder if that would actually be slower because Unity's physics system is designed to do raycast so quickly. Because there are some more complications, because what if there was like a collider here? Well, actually, well, we won't encounter that right now, but it's a good, well, I guess we'll just need to see how it turns out. But basically this way is just going to be the simplest and kind of most naive algorithm, and we can improve it as time goes on. Maybe we can try to write one using our own math instead of the physics system. Okay, so let's see here. Really, all the stuff I did with the different visible layers, I'm not sure if we're going to actually need it. I mean, we'll still have this camera, because it's, well, we will need it, but actually the platform itself won't have a mask. Like this mask image, we can just go ahead and delete it. Because what will happen is we'll feed this collider into the mesh generator, and then it will create the actual mesh that will that the camera will see. Okay, so a couple of things. We'll want to create another layer here. Maybe we could just reuse the cutout constructor, because like I've said, the tags, kind of confusingly, are used for both rendering layers and physics layers. But just To be careful, I think I'll have a separate one. So this will be the shadow raycast, and this will purely be for colliders that well, not even colliders. This will purely be no, yeah, because we will need to do a raycast. So I keep going back and forth. So yeah, this will purely be for colliders that the shadow system will use. Okay, so in that case, we'll need to add another object here. Well, let me. Okay, so I guess I'll just create empty. And we'll just have a box collider 2D. You can see the dimensions here. I think it's 4. Okay, yeah, that's perfect. So now the collider goes around the sprite. I guess it's kind of hard to see because the sprite is also green. But if I move this just slightly out of the way, you can begin to see the outline. And this will be the shadow collider. And I'll need to put the shadow raycast layer. And then I'll want to create a couple more colliders. This will just be to go around the outside of the world. So this will be the world bounds. Okay, and can you draw edge colliders? I think you used to not be able to, but they might have added it. Okay, I see. And now you can drag them where you want. I'm not sure if I can like snap this. Will it let me? Okay, I can't set the points here. Well, then we can just do that. So what I need to do is just set, I need to create a collider that will go around the edge of the screen, so it will have 5 points, because you need to have a point, the last two need to match up. So let's go -10, let's just start negative, I guess. And 7.5, and then it would go 10, 7.5, -10, positive 7.5, and the last one is just a copy. Okay, now you can see that the green border around the world that we'll use to find the ending points of the shadow raycasts. And I guess to future-proof, I'll put this under the camera. Although, that's a good point. Well, I'll leave it like this for now. Probably, yeah, when we start having multiple lights, we'll probably need to like move these bounds around for each light. But for now, we'll just create a mask the whole screen size, so that should be okay. And let's see what happens. Okay, and yeah, this is saying visualize cutout should be appearing right here with what's actually being visualized by the cutout camera. But since we deleted the mask sprite, nothing will show up. So if I change this to cutout constructor, and now you can see I'm moving around the cutout texture, which is what the other camera is generating. So it's still working right, it's just nothing there is shown right now. Okay, trying trying to figure out the best way to do this. Because this object is already a little messy. Well, I guess I'll just keep it messy. And I'll think of this pass as like a prototype, and then we can come back and clean everything up. Okay, actually we will need to use this shader. I didn't test that. Okay, so before we go on, we should make sure the shader works, shouldn't we? And it's supposed to deposit this into the red channel of the image. So I guess I'll just add back the mask just to test it. And put it into the cutout constructor. Okay, and now we can see the cutout constructor has the, it's difficult to see, but by moving the camera, I actually want to move the texture. Okay, now we can see that the mask is red even though it's actually white, and that's just because the shader is only rendering the red channel of the sprite. So let's see, if we change this to like pure blue, oh no, I need to take the red away. Oh, that's interesting. Well, I guess it doesn't really matter. I was gonna say if we take away all the red channel, will the shader still draw it as white? Maybe it doesn't take that color into doesn't try to sample that color. Yeah, because we just transfer the red and then ignore everything else. But yeah, that's fine. Music's a little quiet, turn it up just a bit, but let me know if it's too loud. Okay, so what's our next step? I guess we need to create the cutout, or the shadow mesh. And like I said, right now I'm just going to be like as messy and inefficient. Well, I'm not going to try to be inefficient, but I'm not going to try to make things optimized at all right now. So make shadow meshes. And here we'll need to have a list of all the colliders to appear in the shadow mesh. So basically everything. Well, for now, let's just make it a list of box colliders. I'm actually not sure how we'd extend this for a circle collider. I guess we'd need to... Well, I mean, it wouldn't be that difficult. It's just if this yellow was a light, we'd need to find the 2 points that are straight out from the light that are tangent. I'm sure that's possible. And then we just raycast a shadow out from there. But yeah, we won't worry about that now. So this will be box list. Maybe it should be shadow collider list. And then I can just add this shadow collider to it. And we can delete that again. So we'll just have that one collider in there for now. Okay. So we'll want to have a list of vectors to raycast out from. So how we'll do that is just for every collider we'll take the 4 corners and add it to this list. I think there's an easy way to do that. And shadow collider list. Is there a point in here? That would be easy. No. I guess we would be able to figure it out using the center and offsets. Actually, it has the bounds, doesn't it? Yeah, that'd probably be the easiest to use. So it has the center and extents. Okay, the extents is basically this, like the radius of the box. Raycast starts, add, bounds, center, minus, bounds, extents. Actually, now that I think about it, we need more than just the star vectors because we actually need to keep track of every edge, because each edge will basically have its own shadow quad. Okay, so let's create, I don't think there's like an edge structure that Unity incorporates already, or like a line segment, which would be about the same thing. Okay, so vector 2, oh wait, no, struct line segment. And yeah, we just need AB, basically. Okay, I think the easiest way to do this, vector 2, top left, will always be bounce center plus bounds extents. This is actually the top right, if I remember correctly. And then the bottom left is bounds center minus extents. And then we can find the other two using those 2 points. So the top left equals new vector 2. So we need the bottom left x and top right y. Okay. Top right. Oh wait, no, I already have that. So bottom right is new vector 2, top right x, bottom left y. So this actually is not a list of raycast starts, this is a shadow segments. Oh right, so I need to change the type here. So new line segment. Let's make a constructor to make this cleaner. So public line segment vector 2a, vector 2b. And we'll just store the values. And I guess since I did that, I'll make this a read only, so it can't be changed. Usually a good idea to do with structures, I found. Okay, so there's one from the top left to the top right, and basically every other combination. Should I go... Right now I'm going clockwise. I probably should go counterclockwise. So it's top left to bottom left to bottom right to top right, and top right to top left. Okay, so now we've constructed all the line segments from each collider. Why don't we see if we've gotten this right before we go any further. So for each bar, segments and shadow segments, debug log segment, and I'll make a toString for this. Probably shouldn't use parentheses because that's what is used in the actual vector 2. Okay, and then I need to clear shadow segments here. Alright, so let's just... We want to do this every frame, but for now I'll just do it once so that we won't be spammed. Zero base must be greater than or equal to 0. Oh, did I do the format wrong? Oh, I didn't pass any values. Okay, that was silly. Okay, so let's see. The platform is at... Well, it's not an easy place to actually test this, but... -3, -1. Okay, so let's put this platform at 0, 0. Okay, so now we can see it's right because the platform is a height of 1 and a width of 4, so that means that every one should be at 2 and 0.5. So it starts here, 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 and then back. Okay, so yeah, it looks good. Let's move this somewhere more interesting. Okay, so now comes the fun part. We need to make... I guess we could actually just do this all in one mesh, but there'll basically be a quad. For each segment we'll have one quad. So that means the total mesh size will be, each one will have 4 points. Well, no, they could have 5 points. Right, if one of the quads like went to the side of this. Actually, I think this edge would, because this one would raycast down here, while this one would raycast right here, and so they'd have a 5th point at this corner. I wonder, how would I handle that? Well, I mean, I guess it's not that difficult. Okay, so yeah, unfortunately I can't create the arrays beforehand, because I was going to say if each segment has 4 quadrants, or 4 vertices, then we already know the size of all these arrays, but unfortunately we do not, so... I guess we'll just go with a list then. Private list vector to vertices. Oops. Private list int triangles. Private list. So we'll need yeah, we'll have to do the UVs, even though each UV will basically just be 0, 0. But we will have to pass it this array, which is a bit of a shame, but I think that's it. I guess I'll have, we'll need to create another object for this and everything. But let's just make the mesh for now. And we'll already have this around. It'll be created some other function. Let's just go ahead and do it now. Private void create shadow mesh. Oh, that's confusing. Shadow mesh object. Let's actually call it setup. I can create these lists at the same time. So shadow segments. I don't want to do that actually. Vertices equals new. Okay, this song is a bit loud. Triangles and UVs. And we can basically copy this code up here to set up everything. We'll need to have a texture as well. This stuff down here will be actually just only the test material is temporary. Well, this whole object is kind of temporary, but so we'll have a material, and we won't need to change this at all, so that's a good thing. And this will be the shadow mesh material. Okay, so we'll do that. And so render dot material equals shadow mesh material. And I guess this, all of these should be prefixed with shadow. Now that I think about it. And finally, shadow mesh. Okay, so now I think all this is set up. Oh, we can rename this to be shadow. That's fine. Maybe just shadows. And then the layer for this object will actually be the cutout constructor. I think that's what I called it. Yeah. Because we'll want the cutout camera to view it. Because basically the whole point of this camera is to take a picture of this mesh and turn it into a texture, which we'll use later in another shader as a mask for the actual light object or sprite here. Okay, so now we have this set up. So now our job is to take these shadow segments, and for each segment we'll raycast out from each point in the direction basically away from the light until it hits something. So in this algorithm we actually only want to quit when we hit the wall. shadows. Other ones we might care about other colliders, but not this one. So I actually want to change this to not be in the shadow raycast. I guess it's kind of silly for it to be a collider now, but it's okay. Alright, so let's get started. For each segment and shadow segments. So we'll basically just want to get the endpoint, and then we'll need to see if each endpoint is on either a horizontal or vertical collider. So how, I think, so technically, I mean, normally, unless light is actually inside a collider, there's no way that a segment could project its shadow onto two opposite walls. Well, no, that's not true. Because see, if the light is here, it's not inside the collider, but the angles are such that they would, one would hit the top and one would hit the bottom. So there is actually that possibility that the mesh would have 6 vertices. Is there any way that it could have... Is there any way it could go all the way around and have 8 vertices? I'm not sure. We don't have to worry about the corners. This one go down there, and this one go down there, so it's just 5. But we know for sure there could be 6. I think that with, if every collider is just made up of a bunch of rectangles, I don't think there's any way that it could go, like, cover 3 walls, or touch 4 walls, I guess I should say. But, I mean, I think that if that does happen, it's not going to be too difficult to fix. Okay, so what do we need? If we're going to raycast, we'll need, I guess, just the point, the collision point with the wall. So private vector2 get wall collision. We'll also, up here, we'll need the lights center. And we'll only be working with a point light in this system. I think even in the final version, that's all we'll worry about. So, raycasting is actually really simple in Unity. So raycast hit 2D, hit equals physics 2D, and then you just call raycast, and there's a whole bunch of different versions of this, but for us we'll just need the origin, which is the point, and then we'll need a direction away from the light. Let me see if I can get my math correct. I think it's the light point. I think I have this backwards, don't I? So if you want to get the direction to move towards something, it's final position minus the start. Yeah, so you actually want to go the other way. I have this backwards, which definitely could. It'll be easy to tell in the final version, so I'm not too worried about it. And we'll also... Oh, right. So the point is a vector 2D, and then this position is a vector 3D. And so Unity is not sure basically if we want to subtract 2 vector 3Ds or 2 vector 2Ds, so it's throwing an error here. So you just gotta let it know that you only care about the vector 2D form. And then we'll call normalize to get a unit vector. And distance, let's see. Well, the longest distance would be from the center out diagonally, which would be something like the square root of 10 squared plus 7.5 squared. I guess I could figure that out real quick. Okay, that's definitely 100, so 7.5 times 7.5, so 56 and a quarter, plus 100, and I just want the square root, okay, so 12 and a half. So that's the farthest length. I'll actually go up to 13 just to not worry about rounding errors. Okay, now we're good there. And so if the hit collider does not equal null, that means we actually hit something. And we'll well, I guess we should always hit something, because that's why I made that length 13, but then we'll return the point, which gives us the point in world space that the collision happened. Is there some way to get, what's this centroid? Interesting, I'm not sure what that means, I'll have to look into that. The distance, obvious, the normal. Okay, well this normal can tell us which side of the collider we hit, so that might be useful. So I guess we should return that as well. It's a point. Okay, let's just return if it's successful or not. So we'll want out vector 2 hit point and out vector 2 hit normal. Or should we just return the whole raycast hit? Well, no, this is fine. The only reason I think that is because in the future we'll need to know, like, specifically what collider we hit, I think. But yeah, I'm getting far ahead of myself. Let's hit normal and we'll return hit. Collider does not equal null. So vector 2 hit point and vector 2 hit normal. And so, like I said, this should never fail, so I'm not even gonna really check if it's successful or not. And this will be segment A. Hit. Oh yeah, out, hit point. Out, hit normal. Okay, and for now I think I'll actually ignore the normal and we'll just pretend that every vector is 4 points. And then we can kind of play around with it and see if this works simply. So what would be the order we need to add these? So if we say, let's move this. So if we're testing this segment, oh, well, let's not do that, because I want it to both be, okay, here. So once we raycast out here and then out here, so we need it to go counterclockwise, so it should go segment. Okay, so actually this segment is BA. So I guess, yeah, that, or AB, because it would go like that. So I guess we can add A, B, and then B's raycast point, and then A's raycast point. Okay. And that should always be counterclockwise. I guess that's what we'll test. Okay, so shadow vertices, add segment B. And the reason that they have to be counterclockwise is because if a triangle is clockwise, then Unity will interpret that as facing away from the camera, and so it won't actually render it. So that's why you need to do anything that you want the camera to render has to, they call it, the winding of the vertices has to be wound counterclockwise. It's something that I frequently mess up because for some reason I have a hard time telling the difference in code when I'm ordering them, but luckily you don't have to get that low level super often. Okay, so we'll actually test segment B first, and then we'll just add the hit point to the shadow vertices. And then we'll do the same thing with segment A. Wait, did I do this backwards? I think I did. So this is counterclockwise from the middle. So that means this point is A, and that point's B, so we should actually add A first. So A, B, B, A. Okay. So I got this part right. We need to add the first, or the second point's collision into the vertices first. And then A. Okay, so now we've taken care of the vertices. We need to also add the triangles. So I actually need to keep track of what index I'm on, because the triangles, where did I make that before? Yeah, right here. So basically these three numbers define a triangle on the mesh, and this basically says the triangles are wound with the second vertice, which is here, then the first vertice, and then the 0th vertice for one triangle, then the next one is 3, 2, 0. So I need to kind of keep track of the numbers so I can do that here as well. But for now we're only gonna make 4-point meshes, so that makes my job here a little easier. Okay, so let's actually do a for loop so I can get the segment index. Not that. And then segment, oops. Okay, so good there, and that means this index is basically, or not basically, it is segment I times 4. So the first triangle is, again, if we imagine the shadow box going out like that, the first triangle is 1, 2, 3, and that's counterclockwise from the middle of the triangle. And then the next one would be like this. Oh wait, no, because they have to both have this diagonal, so it would actually be 0, 2, 3. So yeah, so it's 0, 1, 2, and 0, 2, 3. shadow triangles, add. It's a little awkward how you have to construct these. Okay, so let's do it this way so I don't have to do segment times 4 6 times. The vert index A is segment I times 4. Oh, I'm missing semicolon. So yeah, it's vert index A, and then B is +1 because we added it here. And then the next is B's raycast. So that's +2. And then we have the same thing except it goes A, B raycast, A raycast. Okay. So now the only other thing we have to do is make the UVs, and the UVs are very simple because we basically just want this collider to just be pure white, so we really just need to give it some value. It doesn't really matter what. Now that I think about it, we might not need this list. We could just pass it, just create a new array that's the same length as the vertices, because that will be initialized to 0, 0 for everything. Okay, so once we're done here, we'll just need to set up everything in the mesh. So we have the shadow mesh, and how you do that is just setting them like this. I think, is there a simple way? Okay, you can call this probably this function is better, although I'm not really sure if there's a difference. Oh, this one lets you set it with a list, so I mean, might as well use this. So shadow vertices. What's it like? Oh, because that needs a list of vector 3. Okay. That's a good point, actually. But we don't actually care about what the z-coordinate is. And then shadow triangles. Oops. What's it not like now? Interesting, so this is more complicated than I thought. It needs a submesh. I'm not even sure. I'm not sure what that is. So I'll just assume that we have no submeshes. If this doesn't work, I'll just come back to it. And so we don't have a list of UVs anymore. So I'll just do it the old-fashioned way. And again, this will just create basically an empty array of this length. Doesn't it look like that? Pompously type. Oh right, UVs are vector 2s. So yeah, this just creates, there should be one UV for every vertice, so we create an array of the same size, and every value will just be initialized to vector 2, 0, 0, which is all we want anyway. So now we need to clear all these temporary lists. Okay, so is that it? I think so. So I need to call setup shadow meshes here, And every frame, before we render, we'll need to create the shadow mesh. And the last thing I need to do is set the material, I think. And also give it the light point. I'm not sure what shader we'll give it. Where's the material? Right there. So this will be shadow cut out material. So yeah, it should be unlit. I'd kind of like to do the sprites. I'm not sure if it will work because I can't set what's the word? I can't set a texture for it. But the reason I want to do sprites is because I can set this pixel snap, which I kind of want for my mask. But I guess I might have to create that shader myself. So we'll just do an unlit. Is that the simplest? Yeah, it's just this color. So now I won't even have to create a text. I mean, test texture. Okay, so let's see if it works. Okay, looks. Okay, so it has something with 16 verts and 8 tries, but that does not look like how the shadow should. Doesn't. It should move. I also can't see it, even when I turn around the other way. Yeah, so something is wrong here. Why is the scale like that? Oh, that's probably because I left behind some code. Yeah, we don't want to change the scale. I don't know if that was the reason that it wasn't showing up, but it definitely didn't help. So now they're in a more reasonable place, but I still can't see them. It says it has 16 verts and 8 triangles, but that makes sense. No, it should have, for every edge, it should have 4, so yeah, 16 verts. Oh yeah, I guess that is right, because 2 triangles for every quad. But yeah, something is not right, because this shape doesn't look correct and I can't see it anywhere. So maybe if I, let's see, how do I change this to wireframe? Okay, I saw something there. Okay, so yeah, it is just... Okay, yeah, it's not gonna move with it because it's being regenerated every frame. No, that is kind of weird. Even when I paused it, it's not moving. Okay, that tells me something else is wrong because it's not even showing up in the editor scene, I think. Yeah. Oh, you know what? I think... Or no, is that a problem? I thought I might have the coordinates messed up, but no, Y is... Yeah, the screen is looking... or the camera is pointing in the Z direction, so Y is up. It looks like it should work. So obviously this wireframe is actually the platform and not the shadow, even though the shadow says it is this rectangle. But actually this shouldn't be right either because it has no line down the middle. Okay, so how do I figure this out? Actually, these vertices, like, is it giving world positions or local positions? So I think bounds, yeah, this said bounds in world space, so these are world positions. I guess it doesn't matter as long as the object is at 0, 0. Which it is. I'm a little surprised that nothing's showing up. Maybe it's this. I've never used this function before, so. I like this song, but it's a little loud for the stream, so. I'll just use, oops, not vertex, but for count, these accessors and see if that is actually the problem. Yeah, maybe the submesh is, like I thought, actually going to give me an issue. Okay, so what I have to do is just cast this to an array, because it doesn't take a list in this form. I have a feeling this is all that the function was doing anyway. Oh no, that's not the issue, unfortunately. Let's see. Still not showing up. If I move this around, does that affect the mesh at all here? I wish there was a way I could inspect like the mesh itself and see what values it has inside. I don't think there's any way I can do that though. This camera, yeah, it's cutout constructor, and I still have the visualize cutout, but nothing is being displayed on it. So even if I change this to visible, yeah, nothing shows up still. So let's just do the first segment maybe. And once we can get that right, we'll go farther. Okay, well that's interesting. At least so it says, yeah, I'm put out the hit point. I'm passing segment points. So maybe it's an issue in the ray casting. Log hit point. Let's just see what this returns. I'll go ahead and just call this once so we won't be spammed with debug logs. -2, -5. So that doesn't make sense because the y's should both be -7.5. So is it colliding with this collider even though, like, the layer... Oh, you know what? I did forget to set the raycast layer. That is a problem. So raycast layer equals layer mask get mask, and we just want shadows, I think. Let me make sure. So the world bounds is the only thing we want. Okay, so shadow raycasts. Okay, so yeah, this was probably the issue. Now if I add the mask to the raycast function, it will only collide with colliders in this layer. So basically only the world bounds right now. Okay, so now it says 0, 0, which means it probably didn't hit anything. Oops, I didn't mean to do that. So I guess now the next option is to debug this raycast. So there's a draw line function here, which is really nice for raycasts, I found. Although, a little annoyingly, it does not have the same syntax here. But the start is point, and then the end is actually hit point. Well, this will be good if hit point is 0, then it won't actually show anything. So instead, let's do something like this. Maybe I got the direction wrong after all. Okay, so and we'll do red and a duration. I'll just do 10 seconds. Okay, so the raycast is working, but it says it's not colliding with this. How come? It's in the shadow raycast layer. Oh look! Now the mesh is going up here. That is weird. Oh, because it's both going to 0.00. Okay, it doesn't have anything to do with the raycast actually. So I got the direction right. So why is there still an issue? World bounds. It's in the shadow raycast layer. Okay, let's set this to debug, and that way I can actually see the raycast layer there and make sure this. Okay, it still says nothing, so I must have spelled something wrong. Okay, so layer world bounds shadow raycasts. Looks right. Alright, let's just debug this. Okay, it's not gonna give me anything useful. Maybe if I call toString on it? Oh no, that's probably just gonna give me what I just got. Yeah. The least you could do is give me something good there. Okay, well if it's an integer, if it's 0, then we know it's not being set right, and it's not. I don't really know why the get mask is not happy, because the whole point of this is that it's supposed to return a mask given by the names. Oh, shadows raycast. Okay. And now it looks like it's working. Although, interestingly, what's this red? Oh, it's the cutout visualizer. Okay, so now if I move this a little over, we can see it. And if I turn this back on, yeah, we can see the actual collider. Pretty good. It does seem to match up, although it is a little weird that the editor raycasts don't match up with the actual mesh. And I wonder why that is. Because they're exactly the same. It's a point minus light point position. Okay, well, I won't worry about it for now. Okay, so now I'll take away this, and then we'll just run every time, and we'll want to get rid of this debug log, because that'll slow down everything. So now let's get it to update in real time. And hopefully that won't slow down. Well, before I do that, let's see how much frame rate we get. Oops. Okay, so about 100 frames a second. Oh, because it's still rendering every frame. Yeah, if I comment this out, I just kind of want to get a baseline and see. Okay, well, it's not much faster actually. Maybe we can even see the profiler. This will slow down the game quite a bit, but. Yeah, so right now it's mostly yellow, which is I think idle, because barely anything is going on. Yeah, player update time, it's just waiting for target frames per second. And so now if we turn this back on, yeah, so rendering is actually really simple. I mean, it doesn't seem to take up much. Which is nice. Where is it again? Debugger. Gosh, I was just at it. Okay, profiler. So now, yeah, rendering is a little thicker, but it's still not that bad. If we pause, yeah, camera render takes up 3.4%. And the good thing about rendering is that for a 2D game, it's not likely to increase a whole lot unless you add a whole bunch of different draw calls, which unfortunately we will have to have one draw call for every light in order to construct our image. But I mean, for 3D games there's several dozen draw calls every frame, so I think it should be okay. I don't think there's any faster way to make this cutout texture in Unity. I'm not sure how they do it in Celeste, it doesn't say. Let's just leave that up there. Okay, so now let's enable building this mesh every frame and hope the frame rate doesn't die too much. Oops, I just commented it twice. Okay, so what happened there? What's that blue? Oops. update. Okay, so that was like the first frame, I guess. Oh, for some reason this took a lot longer on the very first frame. Cut out update. That's weird, it says update took... Oh, it's because I don't have this deep profiling on. But you need that in order to actually get the actual function names that cause some of this stuff. Okay, so yeah, make shadow meshes takes a long time. Okay, so it's doing the ray casts. That makes sense. I guess it probably takes a long time on the very first frame because it's having to like set up all the colliders. Okay, let's look at the physics down here. What is this yellow line? Kinematic bodies. That's not right, is it? I guess it is, but I don't think we have any kinematic bodies. UI, we don't have any UI. Okay, but as we can see, we're still not actually bound by anything we're doing because this yellow is all basically just idle time. And we still have a really high frame rate, so every once in a while it does do these dips. But I don't think that's anything to worry about. Okay, so we're good so far. I guess we should leave this open and then actually move around some objects and see what happens. Okay, it does seem to update. And I don't know why these debug lines are definitely not correct. Okay, and yeah, but that's interesting actually. So the lines, when I put the thing here, I guess the mesh goes clockwise. Why is it sticking? Oh, it's saying it doesn't reach. So maybe the length isn't long enough. Oh, of course not, because I was measuring by the radius, which is only that long. But if the collider is all the way up on the edge of the map, then I actually need to do it by the total length and width. Okay, and we can see when it gets to this point, it's actually clockwise, so I think I got the winding wrong after all. But it looks like things are pretty much working. There's a couple things we need to update. And actually the frame rate still looks fine, even though we're moving it around every frame, so I'm not too worried about that. Okay, so let's bring back up the calculator. So 20 times 20, that's, yeah, 400, and then 15 times 15 plus 400, and then we just need square root, okay, 25. And then again, I'll just add a little more for rounding. And that should fix that one error where the mesh snapped to the center of the world. Yeah, so now it goes all the way around no matter where I am. Okay, so it looks like I did get the winding wrong, annoyingly. I was pretty sure I did it right. Okay, so here, this is A, so it goes A, B. Okay, so I guess this is different for every slide. That's kind of annoying. I need to find a way to set this up so it works automatically. Okay, so let's add all segments. Okay, so this seems to work. You know what? Maybe I got it right, and actually the clockwise winding is going to work perfectly, because if the vertex is wind clockwise, that means they don't actually need to create a shadow, because they'd be completely covered up by the other face. Okay, so interestingly here, when I move everything around on the profiler, we're getting a lot of dips. I'm not really sure what that means, because it doesn't seem like the blue part is actually taking up any more time on those frames. I guess if I pause it, I can check out one of these frames and see what's going on. Because here it says the update time takes up a lot, but then down here, for some reason, the update time is much shorter, but the render time as well as the script behavior update, which has our cutout render update, which has to make shadow meshes. The time that takes does not seem to really change. Yeah, so the render is the green, and then shadow meshes is blue. So I still don't think anything we're doing is affecting it, although I'm not really sure why moving this around seems to cause the player, the time generator, to stop. That's kind of freaky. I'll have to read up on what that means specifically, but I think we're still okay. And so obviously one issue here is that you can see in this corner, and especially on our cutout, I'll close this for now, that here's what I was talking about, where sometimes shadow might have more than 4 points, so it needs to actually go to this corner. And how we'd figure that out is by looking at the normals returned from the raycast. From that, we could see which wall is being hit, and then we could see that if the normals don't match up. So like if one normal is horizontal and one is vertical, that means that we need to add a corner. But then if, let's see if I can, I don't know if I can get, actually, yeah, the way I was thinking about it before, yeah, okay. I was gonna say, I'm not sure if there's a way that any shadow can actually have 6 vertices that we'd actually be able to see. So I'm gonna get rid of this because this isn't correct for some reason. Yeah, to me it looks like, yeah, the shadow is working perfectly. So it's a line from here and it basically goes out. So the thing is, so this point, yeah, I'm trying to see if there's any ways that it would have 6 points. Basically, if one side could somehow hit, oh, right here. If it's very wide and you get very close. Oh, but see, but these are the actually it's very interesting the way this works. So the shadow actually doesn't contain the collider itself. Yeah, we can look in the cutout. which that is so I think I actually did wind things the wrong way. But the good thing about that is that it removes the possibility of there being a 6 vertice shadow. But it creates a bigger mesh. Like there's this unneeded cutout right there. Okay, so it looks like I wound things wrong. If I reverse this, let's see. I'm trying to figure out how to reverse it without just. I guess I go +1 and then 0, 2. Okay, now these comments are wrong. I'll have to go fix it. Okay, yeah, this is better. Because now there's always only one face that creates a shadow. And the other vertices are still being created, but they are all wound clockwise. So this is actually more efficient. It's going to be a little bit difficult to compute because we'll have to take into account 6-point shadows basically right here, because we actually want the shadow to go up like that. But it won't be that difficult to do so. I actually haven't tried to move the platform around. Oh, what's going on there? Oh, I was moving it into Z. I guess I can turn it back into 2D. Okay. Oh, there it messes up because the platform's actually outside of the collider, so it doesn't really. It's being returned to 0. We might need to fix that in the final game, but I think we'll be okay for now. So it's interesting, here the light actually gets hit by 2 sides, so we have a mesh that goes like that, and then another one, then this other one that goes like that. Let's start with 2 platforms and see if that affects the speed. And then I'll need to add both of these here. Oops, yeah, I have to actually add the collider, not the platform itself. So it still works fine. We're still getting a pretty good frame rate, although it seems to be dipping a little now. So if I open the profiler, let's see. Oh no, still. No, definitely I think the behavior update has started taking longer. Let's see what happens if if I disable one, it won't really change anything here. Or, I don't know, is it really that much different? So, shadow meshes, it took about 0.72 milliseconds. And most of that was raycast. That's actually pretty expensive, but so let's remember that, about 0.75, and then if I remove those again from here, let's see if it's much different. I guess that would be about 3 times, but okay, yeah, so it's 0.3. So yeah, it does, that's the same. It adds about 0.2 milliseconds for each 4-pointed collider, which isn't super ideal. And that's just, luckily the render time doesn't seem to change, it's just making the mesh. So I think I think it's ray casting, unfortunately, that is the slowest, it seems like. And the set vertices is super fast. That's good to see. Almost all the time is the ray cast. Because it's getting called 8 times, and each one is 0.8. I'm surprised. I thought it would have been a little faster. Because, I mean, there's not that many colliders it has to test against. But anyway. So now if I add those colliders back. But yeah, like I said, I'm a little surprised that the physics is pretty slow, but I'm not sure if our math would be much faster. Well, maybe it would. I guess it depends, like, because the reason I'm using raycast is because we need to find the edges of the colliders, and this is the easiest way because Unity can do it for us. And then also, like, maybe we wouldn't want the shadow. Like if it hit this collider, maybe we'd only have the mesh go to here. I guess that doesn't really matter. So I guess the question is it, are the raycasts the bounding, or is it the size of the mesh? I think it is like the raycasts are the part that slows everything down, so yeah, at some point we'll maybe replace this and use our own math just to basically raycast to the wall, and we won't worry quite as much about trying to minimize the number of triangles, because it seems like the shader is really fast. But yeah, anyway, it's pretty cool. I'm happy with our work today. So yeah, thanks everybody for coming by and watching, and putting up with my sometimes silly mistakes. I can't believe I misspelled shadows, but whatever. Oh, I better delete this since it's wrong now. But so, yeah, we'll have a lot to do to improve this. I think we might just keep it how it is for now, and then continue on with the rest of the project until we basically get a masked light. So maybe I'll do that tomorrow and do some more shader work. But if you missed part of the stream, or you want to catch up on any of my streams, I will upload everything to YouTube. You can check it out in my channel description, or by typing !YouTube in chat. I also have a Discord channel that I love for more people to join. You can talk to me or other viewers there. It's pretty small right now, so if you want to get in on the start, feel free to type !Discord in chat, or check my channel description for an invitation link. Besides that, you can also look at my Twitter, and I post stream notifications there, or feel free to follow me here on Twitch or YouTube. And again, thanks everybody for watching. I really appreciate it. I hope you all have a great night, and I hope to see you tomorrow. Alright, bye bye.